We spend a lot of time on like Protocol Labs network events like IPFest Camp, Phil Lisbon, like some smaller, smaller events and like a more like a private things were happening. We hosted meetup like Peer-to-Peer Networks Summit with Live Peer Ceramic. Who else was there? Us and someone else. And Filmine. Oh, Filmine, yes. Really great in Lisbon. Really great time. A lot of meetings. You know, getting a lot of feedback for Fluence, meeting people, and so yeah, it's been super cool, super useful. I guess like, you know, now actually like our core team heads next week to to Georgia, where we have our like internal site sort of like summit gathering in person to work for a week together, which happens right now like maybe once per year, but we wish it to happen more often, but that's you know how the world works right now. Anyway, yeah, it's been super cool here in Lisbon, but let's maybe move to technical updates for the October, engineering updates and demos. I know that we have a couple of presentations from the core team members, and we have demo from the last hackathon that we supported, which was like Morales hackathon. Yeah, so should we start from you know, hackathon demo or?
Thank you so much for giving us the opportunity to present our project. I wish to share with you that I have been following Fluence for considerable time, and it's wonderful to be here in the community call. I wish to share about the initiative. So can I share my screen? Yeah, there are a number of things which I wish to present. So we'll, how much time will I have for presenting? Anna, if you can share that.
10 minutes, would you?
Oh, okay, fine. I'll keep it short and quick, basically. Fine. Yeah, just a second. Okay, so here we go. Just a second. Yeah, so are you able to see my screen?
Yes.
Okay, fantastic. So let me share what exactly we are trying to do and how this entire project and the problem statement that we're trying to solve. So basically, we are focusing on a mobility sector. And in mobility, the biggest challenge currently is the road accidents and the road incident management that every government faces in South Asia, even in South America, Africa, and certain parts of North America. So I wish to give a quick background of where I'm coming from. I did my undergraduate research both in Delhi as well as in MIT Boston, and working on a project which was focused on distributed network. And basically, I've been working with the government on a variety of initiatives around healthcare, around mobility. And in this hackathon, what we were trying to do was utilize Fluence peer-to-peer infrastructure and reduce the bottlenecks that we face in the centralized infrastructure. So our mission basically was how we can capitalize on the key strengths of a distributed environment and a peer-to-peer infrastructure of Fluence for doing road incident management and organize it in 5 different roles. So the 5 roles were basically of a citizen who reports a road accident or a road incident. The second is of a police cop or a person who is in charge of handling a particular incident, providing the requisite ambulance needs or the first aid needs in case of any accident. And the third basically is of the admin or the government ministry who is involved in charge of the overall structure. So basically in this particular project, I'll very quickly begin with a quick demo, a video demo, which will help you understand where we were coming from. So here's a small demo. Our project is divided into 5 different roles. So I'm beginning with the citizen role. So in the citizen role, we can create an incident at a particular point of time, use Fluence as a peer-to-peer infrastructure for sharing it, and also have this particular incident record in a method where we have a snapshot or a video stream. So we were using live peer on open source video streaming along with the peer-to-peer infrastructure, the aqua and the marine ecosystems that are available. So here you can see a particular incident that has been recorded. Now, this particular incident gets saved and is shared. So we'll share the exact IPFS and the Filecoin integration also that we did. In fact, we got very good support from the GitHub repos, which are available on Fluence network. We are still learning Rust. So some of the things that we did was based on the GitHub examples that are there. So here we have the second role, that is of a police cop. So a police cop is basically responsible or is assigned to a particular incident and reports that particular incident via a particular set of So this
Recording
is the
in
exact,
progress.
I would say, challenge that we were able to overcome using video
Recording
streaming.
in progress.
You have a particular incident, and you can see that this particular incident is assigned to a particular person. And this particular person is then basically rewarded or incentivized based on how that particular person handles that incident. So here you can see a particular live video stream. We were using YOLO machine learning library. It's an open source machine learning library for doing a real-time incident detection at any given point of site. So here you can see, these are the first 2-3 roles. Now we are coming to the admin role. In admin role, what we are basically doing is we are doing a text mining, or you can say the problem we are trying to solve is an early detection of road incidents at any given point of time. So in case if there is a particular incident, so we, based on certain parameters and based on a certain data set, we're trying to arrive at a point where we can give up a particular set of schema or parameters or define a set of rules through which we can better handle the incident. So here you can see in the admin section how a particular incident is being managed. So let me very quickly share the IPFS and the Filecoin and the Fluence part. So there is another, so it's a longer video. It's a 6-minute video. I'll be showing the Fluence integrations also in it. But this is basically the storyline. So before I move further, any pointers, feedback, or questions, anything anyone would like to ask before I can move forward? Any thoughts, suggestions? I can move forward? Okay, great. So, so here we had the analytics or the incident analysis in a particular place. So the data that was available to us, it was of multiple sites, as you will see in the video. So this particular data I have taken from Delhi, but there are data sets from New York City, from San Francisco, that you will see in the further section. So I'll be showing that particular thing, like how we are doing real-time incident management in a decentralized manner. So here you have the visualization of the incidents at any given point of time. You can see the severity index, the way that incidents are managed. And basically, this is like a top level kind of a visualization on how a particular incident system is applied in a particular area. So we had the entire analytics being developed for it, the entire system being organized, and also the requisite statistics for the incident. So here you can see cases per incident time at the cases. And also we had the overview surveillance and the incidents prediction. So basically our objective was how we can utilize the strengths of what is available in the Ethereum infrastructure, in the Fluence infrastructure, to basically do a better incident analysis and prediction. So this was the first part of the project. Now let me share the second part of the project. So basically, as you can see, we are doing an overview surveillance also over here. Basically what we have done is we have developed a very simple module of utilizing drones for doing better analysis and you can say communication setup in a particular city. So we'll do that. So here we have the mobile version of the system, which means what is available to a particular person. So you can see the different IP cameras which are available. You can see the different types of objects against which a particular incident is recorded. So if you find a particular object, which is very common in South Asia, like you might find dogs on the roads or sometimes the various kinds of animals on the road. So these are the different detection systems that we have. I've taken the snapshot, this one from New York City. This is somewhere right near Times Square. And what I'm basically doing is I'm trying to find out what are the abnormalities in a particular section at any given point of time that needs to be notified to the system, that is the IPFS system. So we basically take a snapshot in case if there is abnormality, put it on IPFS, and then retrieve from IPFS and share it to the command and control center. So this entire system was being developed. Right now, we are on the testnet ecosystem, but we also have tested it out on mainnet as well. So as you can see that we are using Ethereum plus IPFS plus Fluence in this entire infrastructure. I'll also very quickly jump over to the exact repo and the set of pointers that were helpful. And I'll also like to share some feedback and pointers on how we could have done certain things better and how we can do it further better as we move forward in the project. Any thoughts, pointers, or suggestion till now? Any questions, sir? Anyone?
Well, a lot of things. I mean, this looks like a huge project. I don't know, like you guys did all of it in the hackathon, or like
yes. So basically, we did the two parts of the project. That is the mobile phone version as well as the entire cloud platform version. I wish to share that the idea of the project basically that we did. So that was there in our minds. We had spent some time on the Web 2.0 version of the project way back in 2018. But this is the first time when we actually did it in a Web 3.0 manner. So in 2018, 2017, the pointers were available to us that you can work. So basically the skill set was there that we had, and the execution and the entire, I would say, understanding of how we could utilize Fluence, how we could utilize Filecoin, IPFS. So this particular initiative happened during that, basically.
Super cool. Just like curious to better understand how you guys use Fluence. Maybe like you can show some.
Sure. And and I also wish to ask you a couple of pointers also, which I'll do once this demo completes, on how we could do better in utilizing Fluence. So I'll also share some updates post hackathon that we have done specifically to Fluence in regards to utilizing Fluence. And I'll also like to ask a couple of pointers or suggestions on how we could make it better.
Sure.
So these are certain IP cameras on which we did the real-time detection of incidents and share it on IPFS and basically the admin role that I was talking about. So all this gets recorded. So we have taken a couple of examples during the course. And now let me very quickly share what are the repos of Fluence that we checked on and where we are in terms of project updates, and also a couple of questions regarding it. So I have 4 more minutes with me. I'll try and make it I'll make it quick, but at the same time, I'll share what all we have done. So specific to Fluence, these are the updates on utilizing Fluence peer-to-peer infrastructure in a project. So we are working towards decentralizing key components, bottlenecks in our existing Filecoin solution. Second, we are learning to create decentralized peer-to-peer protocols to replace centralized off-chain solutions that we have currently by swapping centralized service providers like AWS, Azure, and also Google Cloud. Currently, I'm more comfortable with all of them, but I'm trying to swap these centralized service providers for Fluence peer-to-peer infrastructure. So these are the two main objectives currently that we are focusing towards. And I wish to share the repos that we are utilizing in reference to Fluence. So let me share the exact repos. So one, I personally wish to share that the Fluence examples were very helpful during the hackathon. We went through all the examples that are there. Specifically, we looked at the TypeScript JS implementation, since I'm very comfortable with the TypeScript ecosystem. So we looked at the Fluence JS examples and also the Aqua and Marine examples. So basically, this was one particular repo that was very, very helpful. And also it gave us an understanding on how Aqua gets integrated with the decentralized storage system, that is IPFS, using Aqua IPFS system. So you can see in the resource directory, I think it was probably second point, the IPFS integration. So it basically gave us the understanding on how we could utilize the Aqua IPFS library to basically deploy a WASM service to a Fluence node. So this was something which was very, very helpful. There are a couple of areas where we perhaps are very new and I would love to learn more. I think we perhaps didn't have much understanding on timestamp Oracle and price Oracle during the course of hackathon. And this is something where we are trying to learn more and trying to understand how we could better use some of these services in our particular project. So there are certain problems which we can solve using this. The near integration is also something which is very, very important. and we have not looked into that. So these 2-3 areas is something which is still, I would say, in the next 2 months, specifically in the next 21 days, I'm focusing on the near integration in totality and really do that well. And after that, I look at timestamp Oracle and price Oracle after 21 days or 30 days. So that's the plan, the rough plan that I have in terms of learning and implementing it in the project. I'll also share what else, what are the other things that was very helpful during the hackathon, and how, what are the things we are planning for that. I wish to share ceramic integration comes much later. We also have Covalent and a lot of other ecosystems that are coming up. But the ceramic integration, I would definitely try to focus on sometime, I would say towards January. But these are the set of things that we have in mind at this juncture. There are a couple of, before I move on to the Rust peer GitHub repo, which was again super helpful in this particular hackathon. I mean, because we are learning Rust and we find that a lot of things we can derive from this project. So before I move on to that, I'd like to share a couple of collaborations which are happening on the business front, which are giving us some strength and which are giving us some understanding on how we can take the project. So one, there is a company based out of Switzerland by the name ZF Mobility. So they basically came to know about our project, and because it was publicized all over, and they are trying to utilize connected vehicles in Europe for sustainability and efficiency. So they have a data set that they shared with us of 15,000 trips, 45 plus trucks, and 175 plus drivers. So instead of just having this particular project, which is focused towards, I would say, governments, they have asked us if we could kind of customize this project for doing better fleet management. And for doing connected vehicles, arrive at a solution for connected vehicles specific to Europe for sustainability and efficiency. So we're still at the brainstorming stage, but I personally feel that this is where Fluence Rust network, using Rust in Fluence peer-to-peer network, I think that will be very, very helpful, specifically this particular repo. So I'm going to share this with them in the coming call. I already updated them what all we have done using Fluence. And I like to share updates as we move forward on this. So this is one particular update which I wish to share. There are a couple of others also. I mean, we have whenever we get a chance, we do share a couple of things with the community on how we wish to develop a monetization model. So I've written a small white paper on that. It is very much available. I'll share it in the GitHub repo as well, which will help share, how we can sustain this project over time. What are the, how, if someone is using our project, how they can sustain that project in a particular area. And if there is any particular question, you can definitely ask on this. So here we are definitely looking at considerable, so the entire decentralized infrastructure is that of Fluence. The way we have designed the monetization model. So this is another small community writing that I did. I'll publish a blog on it very quickly, and I'll definitely share this across. So this is another feature that we have done. So I just wish to share on the Rust part. That is the Rust peer ecosystem. What should be the manner in which we should be, you can say, piloting some of the things we are doing further in using Fluence, and what would be the appropriate manner through which we can get, you can say, community help as we scale the project forward. So this is one particular question, because there is a lot of learning that is happening at this juncture. I wish to share that we are still beginners. We are not even in the intermediate stage or advanced stage, but we definitely are finding our learnings very nice, and we wish to take this forward. So just an open question to everyone in the community, like what has been their experience. This is my first community call, so I would love to hear on how, what are the ways through which we can expedite our learning on utilizing Fluence as a peer-to-peer infrastructure. So with that, any questions, any feedback, I'll be more than happy to answer.
Well, I guess some highlights. Basically, Rust node, Rust peer is the sort of main implementation of the Fluence node that you run as a kind of where you run your backend. Okay. And basically, like when you think of the backend stuff, this is the default peer implementation that we recommend to use. Okay. And when you think of using Fluence on the client, in a browser, on a device, there is a Fluence.js, which is basically sort of something between the client and the peer. So it's kind of like some lighter Fluence network peer. Okay. but its usual role is to be used in kind of in the role of the client, or like which initiates Aqua requests, but you also can, you know, reach the other client and execute function call there via Aqua.
Okay.
And there are a few other things that, like, important things that are coming, and I hope, like, guys will do some updates on it, like registry and Fluence CLI, which would also be like very important thing that we recommend to use when you build on Fluence.
Okay, registry. Okay. Okay.
Yep.
Great. Thank you so much. One quick question, follow-up question on this. I wish to share that in reference to differentiating where to use Aqua and where to use the marine ecosystem. And if you can share some thoughts or pointers on that, like, I mean, both of them are very nicely documented, and there are a ton of good examples available. But love to hear more on what's what is the basic genesis of scaling up a project with either of these ecosystems? I mean, what should we keep in mind while we evolve a project using Fluence, basically?
Yeah, sure. So, like, the basic distinction here is Marine is a WASM runtime. It's basically the code, the functions that you run on peers, and the Aqua is basically the workflow management on top of these functions. Sure. If you, like, you know, if you're familiar with Amazon Cloud Stack, you can think of Aqua, Amazon Step Functions, and Marine is Amazon Lambda. So, like, you run step functions on top of Lambda, and that's
okay. Fantastic.
So that's kind of like the best distinction how you should separate your business logic. Ideally, sure. you should, like, you are using both, right?
Yeah, absolutely. We are using both, but I just wanted to get an understanding on, I mean, what would be the analogy to help me understand more about this. Great. Thank you so much for your feedback, answers, and thoughts. I appreciate it.
Thank you, Manu. That was a great demo. Thanks so much for joining and sharing this.
Sure.
So I guess we're gonna have some couple of updates from the development team as well. Mike, you wanna be next?
We're not through.
What?
No, we're not through. Okay. Yeah. Hi. So hi. One more hi. Yeah. Okay. So let me share screen. So my name is Mike, and I want to present machine department team progress for the previous month. So, and tradition with like a part of presentation that we had in September. So in September, you can see the scheme. So the scheme represents like tasks that we have done, and we like wanted to be done in next month, or like in like couple of next months. And here you can see that with the rhombus, by rhombus, there are tasks that have done in previous months. Or like next couple of months. And the actual progress for October is it. So here you can see that our main direction was like to complete the deterministic track of the support determinism.
Recording in progress.
We discovered two more issues, and we spent like kind of 1.5 weeks fixing all of this. And then we had internal hackathon, and during the internal hackathon, no more issues have been discovered. So I think that we can say that for this moment, so this track is finished. Yes, and no more tasks at the next. Like in the near future, like won't be deserved to this track. Also, the other track that has been finished in October, it was track of testing framework. So we are building testing framework that allow us to like test AquaVM more naturally and in a more easier manner. And we released, or almost released, 2 parts of the testing framework. They're like they're in the PR stage, but I believe that we will finish it until this end of this week. So we are also it's also kind of finishing of this track. And speaking about other activities that we had in this months, so we designed IPOD support specification that will allow us to use to move AquaVM to IPOD stack, and also we designed how canon instruction that was introduced this summer will use IPOD and will based on IPOD. And also, in the next months, our goal will be to implement this IPOD spec in AquaVM. Also, regarding functors, so functors is a very valuable addition to AquaVM. We want to concentrate next month on collecting requirements for functors to make AquaVM more handy to be target of compilation. And then I'm not sure we would be in November or not, but then after collecting requirements, we will design functors and make a document with this specification, complete specification. So regarding instruction track, we haven't done anything in the field of instructions. There were no any new instructions, but in a plan, I'm not sure will it be in this year or not. There is only join instructions that will allow us to express certain behavior in more strict manner. And regarding the last one about hardening, so in order to fix bugs with updates on of all our stack and JavaScript, Marine.js part, and all of this, we added interpreter version to data. It will allow us to catch up outdated interpreters and fix all this kind of bugs with inappropriate updates. Here you can see this slide with this bug with a fork of using old and canon. So actually, this bug was kind of big. As I said, we spent a lot of time fixing it. So by the basic proof of concept is not so big. So here you can see that actually it consists only of this so the main part here is the fault, where we can use canon as a body in the body of fault with up instruction, and in certain case, so when external addresses has several generation, more than one, then this bug, this crash could happen. So, but it was fixed. It was deployed with new version. We tested on internal hackathon, so no more any problem with it, I believe. And in future, one of our plans is to make it more stable in terms of change format data a bit. It will be in this IPOD specification. It will also fix this kind of hack that we introduced in this October. Regarding Marine, in Marine now we have only two tracks. So first one is developer experience, the next one is the refactoring. And for the first track, for developer experience, we refactored a bit how mapped and pre-opened directories handled by Marine, and how they put into the Wasmer. Then on the following months, we want to improve MREPO according to some hackathon requirements these requirements were collected during our last internal hackathon. And regarding refactoring, we are working on refactoring, working hard. And is about completed task, we researched design of Wasmer Watson time. Then now we are working, and it's almost done. We're working on how to design the proper traits for this. And finally, we want to implement all of this. And why it's important? It's important because we want to support modern Wasmer and modern Wasm time, so to add more blue rectangles to the scheme. So here you can see that there is a core, and between core and these blue rectangles, we want to have abstraction layer that will allow us to use different like underlying engines, especially Wasm-Time. And also we have some other updates, like we during this fixing bugs to support conversions in AquaVM, we refactored certain parts like in trade handler in AquaVM. So it made, so this refactoring made it much more understandable and much more, readable. Also, we fixed some minor issues with Marine CI, and probably that's it from the machine department team side. Any questions to Mike?
Yeah. Okay. All right. Amazing. Thank you, Mike. I know that also Felix wanted to tell probably about the network.
Yep. Hello, hello.
Hello.
Let me share the screen. Yep. So we've been deep in our internal hackathon and all this stuff. After that, we've been doing some work on deploying and releasing
Recording in progress.
registries, crates, IO, Docker hubs, and all that stuff. So now users on hackathons and anyone who uses Fluence can update, and it will work with all the fixes that Mike was describing. So that's great. Also, we added a few built-ins to help with the, for example, array slice operation. It's a Python-like thing where you can choose two indexes of the array and get a sub range of the elements. It's useful for some stuff when you have like data that you want to get subset of. Also, we've been doing some work on JSON built-ins. They are meant to help implement functors and control functors in Aqua before they are implemented in AquaVM. So with this kind of stubs, Aqua developers can already implement control functors, and when they will be shipped to AVM, they will be implemented on top of those native implementations instead of those more expensive things that are implemented by both Rust peer and JavaScript peer. Also, we started big work on the design of these so-called spells. This is an abstraction to implement, this is how we call abstraction to implement stateful recurring computations on Fluence. It's an evolution of current scheduled script. Right now, scheduled scripts are stateless, they can't be addressed, and there's a lot of issues with them. The UX could be much, much better, and like a lot of things aren't possible with current scheduled scripts, not even touching the security and economics things. So spells are meant to solve a lot of things. They are meant to solve local routing, where when you have different services on the same peer and you want to route particles between them, you have to know their service IDs. And for that, you can use registry, but since registry is a common resource, it has some limitations of number of records. And for that, you need hierarchy of routing information, and for that you can use spells. So it's an evolution of scheduled scripts, and it will be possible to implement HTTP triggers with that. So when HTTP request comes to Rust peer, it will possible to trigger AquaScript from that HTTP request. That would be pretty nice and powerful. Same things for triggering from peer events like new connection or disconnection that will allow us to implement Kademlia on top of Aqua. And there is like a whole bunch of nuances to implement. We're still discussing it, and there is still how it connects, a question of how it connects to security, it connects to economics, and we will all discuss and design that on the coming summit that we'll have, and we will all gather together to discuss those things. Also, there was a lot of work on DevOps side, so to call it, on CI side. We're working hard on making the whole Fluence stack testable. So when some change happens in one part of the Fluence stack, all the tests of all the other parts include that new change and run again and check whether that new change compatible with everything and whether test passes and invariants hold. That will improve our quality of life and quality of work a lot. And I hope we will be able to share that for anyone who wants to contribute to Fluence, anyone who wants to develop on Fluence. They will be able to kind of use those pipelines maybe in their workflows. Also, there was work on observability stuff. We had alerts implemented and refined and fixed, and right now working on making Aqua powered alerts happen for Rust peers. So it's not just like whether Docker container is up or down or port is open or closed. It would be also whether some complicated logic written in Aqua gives like error or not, holds some invariants. That way it will be possible to check for different distributed properties of the whole network, like latency, conversions, and all this stuff. That would be nice. And we're working hard on it. Some parts are already implemented. Basic Aqua health checks are already there. And as soon as we're done, we will start working on making those changes like usable by other people. So we'll publish them. They're already open source, but we will like package them so other people can use those health checks on their networks, wherever they run their own Fluence peers. So that's what we've been working on in network team.
Amazing. Thank you, Felix. Great update. Anyone has any questions to Felix?
Yeah, can you please share the spell link, the Notion link that was there?
Yeah, we will share it a little bit later when right now it's work in progress.
Sorry.
We will share the complete RFC or some kind of design document with pictures and diagrams when we will be there.
Sure.
A little bit later.
Sure.
All right, great. Do we have anyone else from engineering team wanting to provide some update? If not, I would just tell one thing. So we have this Telegram channel with developer updates with address Fluence Dev. I'm gonna post the link here in the chat. So we're trying to set up like a regular, schedule of updating about different pieces of Fluence development stack. So there are some fresh updates just posted as like in a batch there about registry, like Fluence.js, Aqua, like some of this covered already on this call, like CLI, Rust peer and stuff and so on. So like if anyone interested to kind of like read through all the latest updates, that's the place to look. And yeah, I think that's then if no one wants to share anything else, then that's it for today. 10 minutes. All right. Yeah, you're good. Good. Guys, says we're good.
Blurred guys.
Lord Fluence team. All right. Thanks so much, everyone, for joining today, and see you next time. See you in our community channels as well, and happy.
Thank you.
Have a good
Bye.
night.